All right, so as you can see, things are a little bit less than last week. Our agenda, we're just going to do a review of the summer packet. Our quiz is on Wednesday, and your only homework is just to start studying. I would say just keep reviewing those questions that are in the packet. I'm not necessarily going to give you a whole bunch of extra stuff or extra homework to do. So I took some pictures and screenshots of everybody's responses to the different questions and the problems that you were struggling with the most. So what I'm going to do is just go through and kind of cover all of the ones that we were struggling with the most. And in this case, number one looks, or target one, it looks like number 16 through 20, a lot of people were struggling with. So if everyone could go to target one, page 4, number 16 through 20. So when we're evaluating expressions, that means insert the number in for the variable and then solve. And I think it would be helpful for you to use a piece of paper to just kind of write what I'm writing so you can get the idea, understand the process as we're going through. So if we look at, let's say, number 16, we're going to be taking all of the A's and we're replacing in a -3 in for all of the variables that say A. So this is going to say 12 times -3 minus 4 times -3 to the second power plus 7 times -3 to the third power. Now here's where things can get interesting. When you have negative numbers being raised to a power, sometimes those negative numbers turn positive, sometimes those negative numbers will stay negative, depending on how many times you're multiplying it by itself. And I think that that's where maybe some of us were confused with number 16, for example. So if I was to simplify this using the order of operations, the first thing that I'm going to do is simplify anything with an exponent. So I have 2 parts here that need to be simplified first. This is a perfect opportunity for you to use your calculator if you're not sure. This should be something that you know at this point, but if you weren't positive, you put it in the calculator to be sure. -3 to the second power is different depending on if you insert the parentheses or not. -3 to the second power, just like that, is going to give you a -9 in the calculator. But if you put parentheses around the -3, which is what you should do, because you're multiplying -3 times -3, it will give you a +9. So if I was to simplify this a little bit to get rid of the exponents, what happens here is this -3 squared turns into a +9. Because I'm multiplying -3 times itself, which turns it positive. Then for the other exponent, we are taking -3 and we're multiplying it by itself 3 times. -3 times -3 times -3. When you're taking negative numbers and you're multiplying them odd number of times, your answer will be negative. So -3 to the third power is going to be -27. Right? At that point, now we just have multiplication, and then we would add and subtract everything together. So 12 times -3, we have -36, minus 4 times 9, we're going to have another -36, and then I don't know this, 7 times -27, this is going to be -189. All right, you're just going to put this all together in your calculator, -36 minus 36 minus 189, we get -261. All right, I feel like 17 is good. We just do 1.2 times 3 to the x power. But what's important about this is that you understand that when you insert 3 in for x, just how the problems work with the order of operations. Like you have to do 3 to the third power first. If you type this in your calculator and hit enter, it'll give you the right answer. But mathematically, you have to do 3 to the third power first and get 27. And then do 1.2 times 27 to get to 32.4. For number 18, 2 times 1/3 to the x power, we're going to replace a 2 in for x. And 1/3 to the second power, I do want you to know what that really means is 1/3 times 1/3. So 1/3 to the second power is going to be, it'll end up being 1/9. And I just want you to see that because when you're taking a base and you're raising it to a power, you're multiplying that base this many times. In this case, it's 2 times. So 1/3 times 1/3 is 1/9. So this is going to be 2 times 1/9. That's going to be 2 9. All right, and then I'm thinking that a lot of us might have been confused with this problem here. This is part of the quadratic equation, and it's really just making sure you're inserting the numbers incorrectly and then following the order of operations. But this one's definitely the hardest to do, like just in the calculator. You can't just really type this all in and just hit enter. So you do have to have a good foundation of how to do it by hand. So they give us 3 different values for A, B, and C. You have to insert these into the correct value. Just make sure you understand, like when you're raising something to a power, what will happen. So this is negative B. That really means the opposite of whatever B is. B is -4. So negative of -4, or the opposite of -4, is going to be +4 plus, and then we have the square root of all this different stuff. We have B squared. Now it's up to you if you want to just kind of simplify as you go, or if you want to like just put it all in first, then simplify. It's up to you and like how you show your work best. I'm just going to put it all in, then simplify. B squared, just make sure because B is a negative number, you put parentheses around that. It's going to be -4 squared minus 4 times A is 1 and C is -21. I always like to put parentheses around my negative numbers. All right, and now this is going to be all over every single thing. The beginning number, the 4 plus the square root of all of that, all is going to be on top of 2 times whatever A is. A is 1. Once I have it all in place, now it's just time to simplify. All right, so we have 4, nothing to do with that so far, plus the square root. So -4 squared is -4 times -4, which is 16. Okay, minus 4 times 1 times -21. So this is going to be minus -84 all over 2. Now, because we have this double negative here, it's going to turn into plus. With me. And now I can simplify the 16 plus the 84. I'm going to finish my work over here. So I'm just going to write the whole thing. 4 plus square root of 100 all over 2. The square root of 100 is what I would simplify next. That's 10. So I have, I'm kind of going backwards, I'm sorry. I have 4 plus 10 all over 2. And 4 plus 10 is 14. I would do that next. And 14 over 2 is 7. Does anybody have any questions on those ones? I think there's one more though. Is there number 20 with this section? Okay. All right. Number 20, I feel like if you made a mistake on number 20, it was probably just like something simple with adding or subtracting. I think that one was probably the one we struggled with the most. So because of time, I'm actually going to skip number 20. If you wanted to see that, definitely ask me about it tomorrow when I will be able to walk around and help anyone who needs, or at any other time, maybe during IE. All right, the next target, target 2, was all about equations. So let's look and see what questions we were struggling with the most. Looks like solving simple equations like numbers 1 through 11 were actually okay. But it looks like solving inequalities is when the majority of us started to struggle. So if I know I'm skipping numbers 1 through 11, if you're struggling with any of the equations part, please just make sure you ask me if you're unsure about the solutions in the answer key. Tomorrow I will have stations, so if you needed to practice more equations, I will have that for you. But for time, I'm just going to cover these things for now. I'm going to start with I guess more difficult ones. Solving inequalities is the same thing as solving equations for the most part. Just a couple little things you have to remember with when you multiply or divide by a negative, you flip the symbol. And then there is also the graph that's associated with an inequality. I know that the directions didn't say to graph. I included the graph in there, but not sure if the quiz says or not. Probably says that you don't have to graph, so you don't have to worry about it. So let's start with 15. To solve this inequality, I am going to first get rid of all of the grouping symbols by distributing. So 3 times x minus 5 is going to be 3x minus 15 is less than 4. And then this is also a distributive property problem as well. You have to distribute that negative to everything behind the grouping symbols. It's like a -1. So this might have been where the mistake happened, because maybe you forgot to multiply -1 times 2 and -1 times -2x. So this is going to turn into -2 plus 2x. Once you've gotten rid of the parentheses, now it's time to just move all the variables to one side, move all of the constant numbers to the other, simplify, and solve. So 4 minus 2 is 2. So I know that this is going to then just be 3x minus 15 is less than 2 plus 2x. I personally like to always in inequalities have my x's on the left because I can graph better when my variables are to the left of the symbol. This one works out nicely because when I subtract 2x from both sides, I'm left with a positive number of x's on the left-hand side. And to solve this, I would just add 15 to both sides. And I would get my answer if x is less than 17. Out of all the inequality problems, I feel like that was the hardest one to solve algebraically. If I'm looking at these ones, like this, just 2 steps. This one might be like this one, I guess is kind of similar. The only thing about this one is if you were struggling to get your final answer, if your answer looks a little bit different than mine, I will show you this one. If you wanted to solve this problem and leave x where it is, that's fine. You would just subtract 5 from both sides. You get -13 is greater than a -x. You needed to say a positive x. So that's why this one gets a little tricky, because you have to either multiply or divide by -1, which one you'd rather. And then you have to remember a couple of things. -13 divided by -1 is a positive 13. Because we divide by a negative, we have to flip the sign. So it's going to go from a greater than to a less than. And then this is just going to be x. This is maybe the answer that you had there. If this is a multiple choice question, maybe this answer is not there. You have to interpret it also that if you flip this around, it's going to be x is greater than 13 as well. Question? Yes, sir. Spot, can I help you with her? Let me know.
I think because when I flipped the sign, that actually flips the location of the
Yeah.
13.
So this one's kind of, it's simple, right? You only have to really do like 2 things, but it's confusing because you have to flip the sign and flip it again if you wanted 2 variables to come from.
Yeah, it's like let's flip the numbers on accident.
Okay.
It actually looks like.
All right. So these problems here, if we look later on, number 19 was the only one that was a compound inequality. There was really no other compound inequalities in this section. This was just asking you to create a compound inequality. This would be -8 is greater than x is less than or equal to 0. So I think that one's okay. But the most issues that I saw was in this section here, solving literal equations. So solving literal equations means solve an equation, but instead of it being like one variable and everything else is numbers, you're going to have multiple variables. You follow the same exact steps, but the only thing that's weird about these problems is it's not going to simplify to be like x equals 2. It's going to simplify to like x equals 2 minus k over 4m. And that's because you have variables that you can't combine like terms with. So we start simple here, number 20, solve for x. When we see that equation is x minus b equals a. Imagine every literal equation to be a regular equation with numbers. And think back to like pre-algebra when you're first learning this stuff. Like if it's helpful, circle the variable you're solving for and think, okay, what can I do to get this by itself? I need to get rid of this minus b. So you do the opposite and you add b to both sides. It gets x by itself. And you can't add a and b together to be one single number because they're both variables. You don't know what it is. So that's your answer. X equals a plus b. The idea behind it is the same as we're used to, but the answers look different. But of course, they're going to get a little bit harder as we go through. We're solving this thing for k. To get rid of everything around k, we have to look here. This -3 needs to go. We divide both sides by -3, and I'm pretty sure I just left my answer as n over -3. Technically, the negative could move though. This is a negative number, meaning that it has to have just one negative. You could also say your answer is -m over 3, or just a negative outside of the fraction, and then m over 3. Like as long as there's only one negative somewhere, then your answer is the same and correct. Number 22, we're solving for g. What's nice about these problems, if they're all, like if all the variables are being multiplied, you can just divide all the things at the same time by whatever you're looking to get by itself. Meaning I need to get rid of the a and the e. You can just divide by a, e at the same exact time, which makes this question pretty simple because you just divide by a, e, and you're done. You don't have to divide by a and then divide by e. You would then have a complex fraction. You don't need to do that because then you have to simplify that. All right, number 23 is solving for y. Y currently is in the numerator of this fraction, which is being divided by 3. The opposite of dividing by 3 is multiplying by 3. So I'm going to take this side, multiply it by 3, take this side, multiply it by 3. Anytime you're dividing by 3 and multiplying by 3, those cancel out. So we're left with y equals h times 3 is the same thing as 3 times h, but if this was a multiple choice question, 3h would be there, not h times 3 probably. Right, we're still, I feel like, in like the easier part of literal equation, solving this thing for y. I'm sure you remember this from Algebra 1, taking equations in standard form and solving them for y to put them into slope-intercept form. We would just move this 3x to the other side by subtracting it. I forget how I put it on the answer key. Y equals 4 minus 3x is the same thing as y equals -3x plus 4. Knowing me, I probably put it like this because it's in slope-intercept form. But if you have your answer as 4 minus 3x, that's still equivalent to -3x plus 4. And then once we get to number 25, we can start to see that it's going to take more than one step. So if we're solving this thing for x, we have to move everything that's on the same side of it to the other side. There's one term that's just being added to it that we should move over first before we get rid of the 2 that's attached to it through multiplication. So we would subtract 3y first. And in any order, you could say 2x is equal to -1 minus 3y or -3y minus 1. Doesn't really matter. It doesn't even really matter here because it's not specifically asking you to put it in a certain form. So I'm just going to say -1 minus 3y. And you have to get rid of the 2 in front of x. The 2 is being multiplied with x. To get rid of the multiplication, you're going to divide. Now, here's where answers can look a little bit different. Some people, maybe your answer was x equals -1 minus 3y over 2, and that's what you have. That's great. Some of you maybe split it up. You divided each part by 2. It's still correct. X equals -1/2 minus 3y over 2. Still correct. What's interesting though about math is you have to be able to look at answers that might be different and understand that they are equivalent. These two things are equivalent. And on a PSAT or SAT or on this quick little multiple choice summer packet quiz that we're going to have on Wednesday, you have to be able to look and see, because I'm not going to have both answers there, that whichever way you did it, it matches whichever answer is there. Okay. Yes.
If We did it in like decimal form. So
Oh,
we did,
it's-
like 1.5.
Yeah, I just, you know what, I'm just
You
not a
figure it.
decimal person.
Yeah.
I keep everything in fraction form. But if you have negative 0.5 minus 1.5y, that's still fine. Yes, it's perfect. Thank you for bringing that up. All right, and then taking some equations that we use in geometry and in everyday just application problems. We have the perimeter, and then we have the triangle formula for area. So to find the base of a triangle, if we are given the area of a triangle formula and we want to find the base formula, we have to get rid of the 1/2 and we have to get rid of the h, which is the height. So to do that, you have two options really, but if I was trying to get rid of this 1/2, I much rather multiply by 2 than divide by 1/2. Because if I divide this side by 1/2 and this side by 1/2, I then introduce a complex fraction that would have to be simplified. And I just don't like to get myself into that if I don't have to. So what I did was I got rid of 1/2 by multiplying both sides by 2. That was the first thing that I probably did. 1/2 times 2 equals 1. So they cancel out, just like dividing by 2 and multiplying by 2 cancel out. It's basically what 1/2 is. 1/2 is the same thing as dividing by 2. So those cancel out. I'm left with 2a equals b times h. And then if I'm solving for b, I can just get rid of this h by dividing. And that's where I came up with the 2a over h is equal to b formula. It was because of the 1/2 thing that maybe messed some people up with your answers looking different. And maybe your answer is correct, but I do want you to know this would be like the answer that would be one of the 4 choices. And then for the perimeter of a rectangle, we're solving for the length. So the perimeter is equal to 2 times the length plus 2 times the width. We're solving for L. Always move the constant first, the thing that's not attached to the variable that you're solving for. So always move the 2w by subtracting it in this case. We're going to get p minus 2w is equal to 2l. And we're solving this for L. So to get rid of the 2 in front of L, we divide everything by 2. And then here's where things, some people would say this, some people would say that. The answer, the length, is equal to the perimeter minus 2 times the width over 2 is an answer. But some would say that this is not simplified because of the idea that this 2 and this 2 share a common factor. So some would say you would need to separate these into p over 2 minus 2w over 2, which the 2w over 2, those 2's could cancel to just be w. So forget what I put on the answer key. Maybe I put this. Maybe I also put length is equal to p over 2 minus w. They're equivalent. It's hard to say depending on the problem itself what would be on there because this is totally simplified. In fraction form though, there's nothing you can do when it's all together there to take out common factors from all. All right, any questions on any of those literal equations? I hope that that feels better because 90% of you wanted to see that. All right, target 3 was writing equations. So let's take a look at target 3. And we're writing equations in slope-intercept form or point-slope form, which requires us to think back to algebra 1 and remember all of those formulas. Okay, most of us had problems with the later questions, numbers 10 through 13, but I will just quickly go through some of these as well. Hello. Sure. Yep, fine. Okay, so we are going to, I'm just going to kind of go through some of these quickly just so that we can see, but then I'll focus on the later ones. All right, so to find the slope from a graph, my So when you're finding the slope of a line from a graph, pick a point you want to start at. I'm going to start here and then go to another point. I always like to move from left to right. So if I'm moving from left to right, I would go here. Your slope is equal to the rise over the run. In this case, we have to go up and we have to go over. So we have to go up 1, 2 and over 1. So my slope would be 2 over 1, also known as just 2. Anytime the denominator is 1, you can just drop it and say the slope is 2. Something about this one here, number 6, anytime a line goes up and down like this, the slope is undefined. And that's because if you actually found the slope algebraically, you would get 0 in your denominator. You cannot divide by 0. If the slope was the other way, and here's my graph, and this was my line, this slope is a slope of 0 because it is not increasing or decreasing. All right, looking further, finding the slope of lines from different equations. Some of these equations are already in slope-intercept form, so the answer is right there in front of your face. Some of them you have to do something to find it. So number 7, this is in slope-intercept form. Y equals mx plus b. We know the number in front of x when it's in this form is the slope, which means the slope of this line is 3 or 3 over 1. And I didn't mean to circle the x with that. My pen is just a little wonky. Number 8, it's not in any form that we can easily find the slope. So you have a couple options. It's technically in standard form right now. You could use the formula. You could change it into slope-intercept form, whatever you want to do. I usually just do that. I'm just so used to putting this in slope-intercept form. Y equals negative 2x minus 4, so that I can see there that my slope is negative 2. And then number 9 is in point slope form. Maybe you actually took it out of point slope form and put it into slope intercept form, but you can see the slope right from the actual problem itself. The slope is negative 4 because in point slope form, the slope is in front of the parentheses. But then once we got to number 10, this is where we started to get confused with creating the equation of the line in slope intercept form given the information provided. So in number 10, they give a point and they give the slope and they want the equation in slope-intercept form. For slope-intercept form, you need y is equal to mx plus b. You need the slope, you need the y-intercept. They give us the slope. They do not give us the y-intercept. Remember, the y-intercept will be on the y-axis. And in order to be on the y-axis, x has to equal 0. Number 12, they give us the y-intercept. So this one's easier to find it because it's there, but this one's not there. So what you have to do is use only the information you can, that y is equal to negative 3x plus b, because they tell us the slope is negative 3. And you insert negative 2 for x and 4 for y into this equation so that you can solve for where this line crosses the y-axis at. So I'm going to replace a 4 in for y, a negative 2 in for x, and then I'm going to solve for b so that I can find the y-intercept. Negative 3 times negative 2 is 6. I have 4 equals 6 plus b. I would subtract 6 from both sides. 4 minus 6 is negative 2. So I get that the y-intercept is negative 2. So altogether, if I was creating the equation then, I would put that information back into the formula. I know that my slope is negative 3x, but now that I've found that my y-intercept is negative 2, so the equation would be y equals negative 3x minus 2. Number 11, they did the same thing. So they gave you the same exact information. They gave you the slope and they gave you a random point that is not the y-intercept. So you would follow the same process for number 11. Y equals negative 2/3 x plus b is your first step. Then you insert 3 for x and 4 for y here and here to solve for what the y-intercept would be so that you can have that full equation. So 4 is equal to negative 2/3 times 3 plus b. So when you're solving this, don't forget simple little things. Like when we're multiplying negative 2/3 times 3, don't forget that's like 3 over 1. this 3 and this 3 are going to cancel, which is nice. You don't really need a calculator. This is going to be negative, just equal to -2. So we have 4 equals -2 plus b. So I would add 2 to both sides to get that my y-intercept is 6. So altogether, this equation will be y equals -2/3 x plus 6. So numbers 10 and 11 were similar because they gave you the same exact information. Numbers 12 and 13 were different because they require you to do something else. Number 12 and 13 give you 2 points and they want you to create an equation. So in order to create an equation, we need 2 things, the slope and the y-intercept. They don't give us the slope. So what we have to do for these problems is first find the slope, add that other layer, that next step. So the slope formula says take the second y, which is 1, subtract the first y, which is 3, divide that by the second x, which is 0, and subtract the first x, which is -2. Then simplify. 1 minus 3 is -2. 0 minus -2 is 0 plus 2, which is 2. So my slope is -1. Now that I have that, I put it into the formula. Y equals -1x. You can put the 1 or drop it and just put a negative symbol. I don't care either way. And then plus b is usually what you would do. What's nice for this problem is they actually give us the y-intercept. One of the points they give us is the y-intercept, which is 1. So our answer would just be y equals -x plus 1. -1x plus 1. Number 13, that was the longest because they did not give us the slope and they did not give us the y-intercept. So this one takes the most time. So for number 13, we first find the slope. So we'll do that by doing -5 minus -3. Over -2 minus -6. So -5 minus -3 is the same thing as -5 plus 3, which is -2. And -2 minus -6 is the same thing as -2 plus 6, which is 4. So my slope is -1/2 simplified. Now that I have my slope, I insert it into the equation. Y equals mx plus b. So y equals -1/2 x plus b. I insert a point that I like better, kind of like -6, -3 better. So I insert this for x, this for y. Negative times negative is a positive, and this is going to end up just being +3. So I get -3 equals 3 plus b. Subtract 3 from both sides, and I get -6 is equal to b. So I know all together this is kind of confusing, but my final answer will be y equals -1/2 x and then -6. Okay, does anybody have any questions on that? All right. So on to the next part, target 4, graphing equations and inequalities. It looks like graphing the lines, everyone was good. And if you weren't good and you have questions with the answer key and you're not sure why you got something wrong, please see me with questions because I'm going to skip this part. If you just selected this because you want more of it, there will be more of this tomorrow in the stations activity. But what it looks like everybody was struggling with the most was graphing linear inequalities. So I'm going to focus on that. Linear inequalities are just like linear equations. We're kind of doing it anyway. But the main difference is that there's 2 different types of lines. We have solid lines and we have dotted lines. And then we have to shade a region where the solution is. So x is greater than or equal to -2. Anything that starts with x is going to be a vertical line. So at -2, and do these go by ones? Okay, so at -2, which is right here, is going to be a solid line. Sorry, this is not straight. Because anything that's greater than or equal to or less than or equal to is a solid line. Anything that's just greater than or less than is a dotted line because the line is or is not included depending on what symbol it is. The equal to part makes the line included. Anything greater than Anything bigger than -2 on the x-axis would be anything to the right of it. That's why the solution region would be there. For number 10, though, we have to graph 2x minus 3 as if it's a linear line using the slope and the y-intercept. So I would start at -3 and I would go up 2 and over 1 and make a point. But when I go to draw my line, I'm not going to draw a solid line because the symbol is a greater than symbol, which means that none of the points on the line are actually solutions to the linear inequality. The last thing that I do is shade. Every line splits the graph into 2 regions. So we have like this upper region and this lower region. Some of you might be able to identify the area that should be the solution region just by kind of reading the symbol and understanding it. Here's my line. I want the solutions to be anything greater than the line. Your mind should be thinking, okay, here are my 2 options. This looks greater than to me. But some of you might not trust that thinking and you might want to actually test the point. If you want to test the point, 0, 0 is the easiest point to test, but you can only test a point that's not on the line. 0, 0 is not on the line, so I can use that. What that means is you replace a 0 in for y and a 0 in for x and see if you get a true or false statement. This is going to end up being 0 is greater than -3, which is a true statement. Because that's a true statement, that means every single point in the same region that the point you tested in is a solution. So that verifies anything above the line is the solution. Number 11 is going to be like this one, but it's going to, instead of being vertical, it's going to be horizontal. I'm going to skip that for now because I feel like number 12 was probably the one that messed a few of us up because of the negatives. So in order to graph this, I personally would put it in slope-intercept form first. So I would subtract 3x from both sides. I would get -y is less than or equal to -3x minus 3. And then you have to get rid of that negative in front of y. So you would do that by dividing everything by -1. Because you're dividing everything by -1 or anything by negative, just remember to flip the sign, which might have messed the shading up for some. Instead of it being a less than or equal to, it's going to be a greater than or equal to symbol. -3x divided by -1 is a +3x. -3 divided by -1 is a +3. So this is the linear inequality we actually are going to graph. So we start at 3, and from here we go up 3 and over 1. This is a solid line because it's a greater than or equal to. And you can either understand anything greater than the line is going to be above it. It's going to be this area up here. Or if you don't trust yourself, test the point. Test 0, 0 since it's not on the line. 3 times 0 is 0, so we're just going to get this statement since 0 plus 3 is 3. This is false. 0 is not greater than or equal to 3. That means that below the line is not the solution region since that was false. Therefore, that means above the line is. Okay, so that's linear inequalities in a nutshell. All right, moving on then to the next target. Target 5, it looks like a lot of us struggled with systems of equations. That was a majority. So I am sorry about number 2. Number 2, you can see on my answer key, like number 2, it's not even good to graph because you get a fraction as your answer for x or y or both. So the methods that you primarily probably want to work with are linear elimination and substitution. The way that it works is you usually learn substitution first. So I'm actually going to start with number 3. Substitution says you have to have one of the variables equal to whatever else, meaning one of the variables has to say y equals or x equals. In number 3, the first equation is set up for substitution because one of the equations says y equals. Substitution works like a substitute teacher. They come in, they replace that teacher for the day. They're equal. Y equals 2x plus 4 means that you can replace this y here in the other equation with 2x plus 4 because they're equal, they're the same. So the second equation, -3x plus y equals 9, is going to look a whole lot different because I'm going to take this y here and I'm going to replace it with what it's equal to, which is 2x plus 4. So this is going to be 3x plus. I like to put parentheses around the things that I'm substituting in case I have to use the distributive property, which I don't have to in this part. So I have negative 3x plus 2x plus 4 equals 9. If this was not a plus on it and was a minus sign, you would have to distribute a negative to everything. So using the parentheses to just be sure is important, but we don't actually need them in this problem. Negative 3x plus 2x is negative 1x. We get negative x plus 4 equals 9. We're going to subtract 4 from both sides and get negative x equals 5, which means x is equal to negative 5. Yeah, so we divide by negative 1. We have 1/2 of our answer. Once you get one number, it's easier to find the other one through just replacing it in and evaluating it. You pick an equation you like better. I like the first one. Y equals 2 times, we just found x is equal to negative 5, and then plus 4. So 2 times negative 5 is negative 10. Negative 10 plus 4 is negative 6. So we have 2 answers. Our answers will always have 2 parts to it because it's an ordered pair. The answer is negative 5, negative 6 for number 3. That's substitution. The only way substitution works is if one of the variables is solved for. Elimination is probably what your Algebra 1 teacher called it. Don't get confused with linear elimination. Sometimes it's called linear combination as well. It's just elimination. So elimination, the process is that you want to get rid of one of the variables, you want them to eliminate to go away. That happens through addition and subtraction if you have the same variable or opposites. If I take these 2 equations and I add them together, the y's will cancel out because 1y plus negative 1y equals 0y. If I take these 2 equations and instead of adding them, I subtract them, what would cancel out? X. So it's up to you for this problem what you'd rather do. I kind of prefer to add and then just get rid of the y's. If I add straight down, x plus x is 2x. The y's cancel. 6 plus 4 is 10. So we're going to get x is equal to 5. That's one of our answers. You pick an equation you like better. I like the first one better. X plus y equals 6. I found that x is equal to 5. 5 plus 1 equals 6. Y has to equal 1. So that's where we get 5, 1 from. Now, sometimes linear elimination isn't set up right and you're not able to do it because you have to multiply first or you have to do something in order for things to eliminate. Sometimes substitution is not going to work right away because you have to move things around so that a variable is solved for. Now, I know there are other targets that we still have to cover, and I would like to still do that. So we still have exponential expressions. The harder ones looks like almost 100% of you want to see how to do that again. Factoring quadratics, the harder ones, looks like a lot of you want to see that again. Radical expressions, the more difficult ones, and then conversion. So tomorrow, I will start out by completing those questions and those targets, and then we'll end with some like independent practice for what you need to prepare for that quiz.